Today I'm back with a bit of a different video. So we're not going to be focusing on the chemical recycling of batteries today. I'm going to leave that for future time. Today I'm putting together a 6-axis servo-powered robotic arm. Now, I did consider building it from scratch with 3D printed parts, but at the end of the day, it turned out to just be cheaper to buy this sort of kit off of Amazon and focus more on the code and the sort of AI element of the whole project, which is what's really important. So the reason I'm building an arm like this is soon I'm going to be using an industrial shredder to shred up any of the vapes that aren't useful to make power banks with. And this arm is going to be the first version of the sort of AI-powered robotic sorting system that actually separates those pieces of vape into batteries, metal, plastic, and rubbish. Again, I probably could have designed and 3D printed one, but in the future, it's going to be a different type of robot arm, and I'll design that from scratch. But I figured, just for the sake of time, speed, and also cost effectiveness, buying this little kit off Amazon, putting it together, getting all the code working, which is the important part, that's a bit more of a priority. Now, this thing doesn't come with any instructions, so it's going to be interesting putting it together. I'm going to get all the pieces laid out, as well as probably a screwdriver and the other appropriate tools, and we'll check back once I actually get a bit of a better idea what exactly is in here. Okay, this is everything that's come in the kit. We've got 6 of these MG996R servo motors. You can see those there. Got all the appropriate servo horns and screws and nuts and bolts. We've got the actual claw mechanism, which will connect to a servo, so that's going to be interesting. I will probably swap that out for a pneumatic gripper at some point in the future. Base brackets, connection brackets, servo holding brackets, just lots of brackets. And then this little bag of sort of servo extension wire, some zip ties, and then a cable cover, sort of wraparound cover. And then obviously this piece, which is kind of the rotating bit for the end of the arm. So overall, all the appropriate pieces and no instructions. So I'm going to put all this together. I don't have a tripod here, so I can't really do a time lapse. I'm going to start putting it together. I'll probably cut in with a little bit more footage every time a different piece goes together to give you guys a clearer picture of how it all works. But hopefully this won't take me too long. There are a lot of screws in here, so that's going to be fun. And obviously I have trusty screwdriver kit, and that should help me get everything done. As a quick side note, something I would recommend anyone building a project like this to do would be get just a little Arduino and run a very simple sketch on it that's basically just going to write all of these servo motors to 90 degrees, because these are 180-degree servos. And what that'll do is when you're actually screwing all of these pieces together, I'll just put the Arduino down for the sake of talking. When you're screwing all these pieces together, you're going to want to plug the servo into the Arduino and have it holding itself at its center position, so everything's straight. And then when you turn it all on, it'll all lock back into its center position. And that's going to avoid a lot of headaches further down the line. I'm making some decent progress with this. One note would be these little screws with the nuts are quite a pain to actually put together once everything's stuck in. But apart from that, it's going pretty smoothly. So yeah, I would definitely recommend getting an Arduino and writing all of the servos to their center position before you start screwing things down. All right, just a quick update. I've got the base done, and I've got the first 2 axes of movement put together. Now, even when you do set them to 90 degrees, these servos, they aren't perfectly straight on. So there are some sort of inconsistencies, which you'll have to fix in software. But for an $85, you probably even get it for cheaper if you really dig around, $85 kit from Amazon. I mean, it's got all the servos you need, all the metal brackets, and if you were to decide to try and design and 3D print this yourself, the plastic might be cheaper than the kit, but overall the servos, the screws, connectors, everything, it is pretty good value. So considering a handful of software adjustments to make things work properly, it's pretty decent. And so if I plug that in, this one here will go up to 90. And you can see it moves quite smoothly. There's nothing binding. You will need to put some grease on some of these sort of connections, but overall, it is a pretty decent kit. Okay, another update. It's starting to look like a robot arm now. All I got to do is put together the claw side of things, attach that, and then it'll be pretty much done. All right, and I am done. That is the arm put together. Now obviously the cables are a bit messy. I'm gonna have to put a cable organizer on there once I cut them all to the correct length, and I'll get a servo driver and write some code and actually control it properly. For the time being though, I've just got this Arduino connected up to the wrist servo so you can see it moving. I'm gonna have to hold the base down because it is quite top heavy, and without all of these servos powered up, it might just collapse in on itself. But as you can see, that's working. Accuracy wise, I am going to have to do a few things in the software to make sure that these servos are at the correct sort of starting point and finishing point. But overall, I think I'm pretty pleased with the way this has turned out. Look, for an $80 kit on Amazon, yeah, you can see right there, I'll turn the power off. From an $80 kit on Amazon, it's not too bad at all. Putting it together was a little bit difficult because you have to go online and find instructions, and there are a few different versions of this, but it's by no means impossible to do. It's quite a simple assembly. Once you actually know how things go together, it's all sort of cut and dry, same pieces in different places. But overall, that's probably going to do it for this video. At another video in the future, I'm going to ride the inverse kinematics and actually get this thing automatically moving to different coordinates, picking stuff up, putting it down, and really kind of expanding it to do what I need it to do. Plus these cables will be a lot cleaner. But overall, I'm pretty pleased with the way this project's turned out, and I hope you guys, enjoyed watching it. I suppose if you're thinking of purchasing one of these kits, I definitely would recommend you do it. But just keep in mind that it's going to take a little bit of code and a couple of hours to put together and actually get working properly. But anyway, I hope you guys enjoyed this one, and yeah, have a good one.